All right, this is chapter 411, constant ratios and right triangles. So hopefully you've all heard of the Leaning Tower of Pisa. The engineers have been closely monitoring this tower, and it's feared that if the angle of slant ever falls below 83, the tower will collapse. So this is the angle of slant here. Basically, if the Leaning Tower of Pisa slants anymore, it's going to fall, and that would be bad. So with the measurements provided in the picture, what can we determine? Well, I see a triangle here, and we've talked a lot about triangles so far. I also see that it's a right triangle. This is 5 meters down here and 50. So one thing we've talked about so far is Pythagorean theorem. So we could definitely determine this height right here, C. So I could do that real quick. 50 squared plus 5 squared equals C squared. When I do all that, C gets me 50.25. So that's one thing we could determine. But that, I could do the slope. If we thought about this like a line, the slope change in y over change in x. So we could do slope is 50 over 5, and then C is 50.25. They're asking us if we could determine the angle at which the tower leans. That would be this angle right here. And we have not learned how to find missing angles yet, so we do not know how to do that yet. Besides the angle, how else could we describe the lean of the tower? That's basically slope, right? That's how we describe, if you will, the lean of a line, right? Change in y over change in x. So it says draw the new slope triangles on the line. Each should be a different size. Okay, so what I'm going to do is this goes over 5, so I'm going to make sure I go over more than 5. We could do this one. This is going over 10. I'm sorry, this is probably going over 15 and up 3. Yeah, that's 15. We could have done one that was going up 2 and over 10, I think. Yep, 2 and 10. Each triangle, label each triangle with as much information. If this is 11 degrees, then all of these should also be 11 degrees, right? So all the slope triangles have to be similar, right? 1 over 5, 2 over 10, and 3 over 15. Those all simplify down to 1 over 5. And since the triangles are similar, what does that tell you about the slope ratios? The slope ratios are the same, right? All those angles should be the same. So it tells us to write each slope ratio for each triangle as a fraction. We already did that up there. But all of these, 1 over 5 is 0.2. So moving on to the next page, they want us to draw a slope triangle with a change in y of 6. So I'm going to do that over here. I'm going to go down 6. 1, 2, 3, 4, 5, 6. Perfect. And they want to know what the change in y would be. So I'm going to go all the way over until I meet my line. We have to extend that a little bit. But that change in x would end up being 30 long. If the change in x was 40, what's the change in y? Well, what I might do, instead of drawing this out, having x go all the way to 40, I know that the slope ratio is 1 over 5. So my change in y over change in x should simplify down to 1 over 5. So I might just set that equal to whatever the change in y is over my change in x, 40. And then I could just cross multiply to figure out what the change in y is. So we would have 40 equals 5y. So divide by 5, the change in y would be 8. for that. So will this pattern work on all lines? Well, it won't always be equal to 1 over 5. It's not always going to be 1 over 5, just because different lines have different slopes. But we can do the same sort of thing where we set up the slope ratio and set that equal to our ratio when we're trying to find either the change in y or the change in x. So they want us to graph the line 2 over 5x. So that's my change in y. This is my change in x. So I'm going up 2 and to the right 5, up 2 to the right 5. So I'm going to draw a line through those 2 points. What is the slope ratio for this line? Well, it's the slope, right? It's 2 over 5. And if we were to figure this out with a protractor, what this angle is, it ends up being 22 degrees. And then create QPR so that it measures 18 degrees, okay? Using our protractor, it might look a little bit like that. And that is going to end up being a 1 over 3. And again, I'm skipping a lot of this because we would be working with protractors in class. So a change of y of 1 with a change of x of 3. The line x plus 4, we would be starting at 4 here and then just going up 1 every time. Draw the slope triangle and label its horizontal and vertical. So this is up 1 over 1. So this is a 1 over 1. Slope ratio is 1 over 1. And the slope angle ends up being 45 degrees. So with that, all slope triangles have a ratio of 1 over 5. I would disagree with this. Because really the slope ratio is talking about the slope, right? And we know lines can have different slopes. So I'm going to say lines have different slopes. If the slope ratio is 1,5, then the slope angle is 11 degrees. True, we found that out in our notes. I think up here, that was 11 degrees. That's true. If the line has an 11-degree slope angle, then the slope ratio is approximately 1 over 5. That's basically saying the same thing. True. Different lines will have different slope angles and different slope ratios. This is mostly true. But we could have 2 different lines here that are parallel, and they would have the same slope because they're parallel. Parallel lines have the same slope. So what we want to do is fill out the angles that we learned so far in this unit. So we learned that an 11-degree angle, this is already filled in for us, that is a 1 over 5 slope ratio, which is 0.2, and that was for an 11-degree angle, okay? And then, you know, that makes a slope triangle with our change in y and our change in x down here. We also talked about a 22-degree angle. So that was 2 and 5 for 22 degrees. So 2 over 5. And as a decimal, that ends up being about 0.4. And then I think there was there 55? Let's look at the other ones. We did 1 over 5 with an 11-degree, a 22-degree. We did do an 18-degree. That is about a 1 over 3 for 18 degrees. And that, as a decimal, ends up being 0.3 repeating. Okay. And then just to do some practice problems, finding the slope, looks like we're going up 1 and to the right 1, 2, 3, 4, 5. So slope is 1/5. Here we're going up 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6. So 4/6. Then here they want us to solve for the missing angle measure. I see that my change in y over change in x is 2/10, which is the same as 1/5. And then if we look at our little toolkit, 1/5 means that the angle is 11 degrees. So this is an 11-degree angle. With the medium, we did not do 45-degree angles. Okay, that will be in the next lesson, so we'll have to come back to that. 22-degree angle, we know that that was 2/5, the slope ratio. So we know that should be 2/5, and our slope here is x/7. So we're going to set that equal to x/7. We can cross multiply to get 5x = 14. And then 14 divided by 5, x = 2.8. So that's 2.8 right there. And then this slope ratio is 2/5, and that's the 22-degree angle, right? So this missing angle is 22 degrees. Finally, onto the spicy. We haven't learned about the 68-degree angle yet, so we can't do that one. We haven't learned about 79 either, or 45. So these spices we will have to come back to.